All right, let's talk about absolute value inequalities. We just did equations. Now we got to look at when things are different. Um, so here, the distance between x minus a, the distance between x and a, right? So we're taking x and subtracting some number, is less than b. So x is within b units of a. So for example, x is less than 3 units away from 5. So you can go less than 3 to the right, less than 3 to the left. And so what you get is it's a less than distance. You get this and where your x minus 5 is pinned in between. X minus 5 is pinned in between 3 and negative 3. Okay? So this ends up being an and. It's within units. So you're stuck within some distance. You can go 5 to that side, 5 to that side. Nope, 3 to that side, 3 to that side, and you're within that distance. Over here, when it's greater than, you go 3 to that side, 3 to that side, and then it needs to be greater than that distance. And so here you get an or. You get that x minus 5 is greater than 3, or x minus 5 is less than negative 3. Okay, so it's either got to be below here or above here. So that's where you get a greater than distance. And so when you're within, less than, it's going to be an and. When you're greater, it's going to be an or. All right. So how do we solve these? Obviously, you got to set the absolute value by itself. If it's trivial, how often do you get something less than a negative? Never. How often do you get something that's greater than a negative? All the time. And so you get all real numbers. Okay. The first inequality, as is, write the word and if it's less than or if it's greater than the number, and write the second with the symbol and sign switched. So the other one needs to be in the opposite direction, okay? Because if you are going greater than this distance, there's my distance, then I need to go greater than the distance that direction, which if this was a greater than, this is a less than on the other side, okay? And then combine the solution if possible. I would even say if it's an and, just write it as one group, all right? So when it's greater, it's an or. When it's less than, it's an and. And so what you can see is Goreland. Okay, once you have the absolute value by itself, Goreland. Greater than is or, less than is and. Goreland. Whatever you want to remember stuff with. All right, so here it's a greater than, so it's an or. And then you can add 7. You get x is greater than 11, or add 7, x is less than 3. And you would see here's 3, here's 11. It's either greater than 11 or less than 3. Here it's an and. And so here you can split it up to the original and flip the sign. So instead of being less than 36, we're greater than negative 36. But now since my negative is less than this, which is less than 36, you can write it all as 1. And then when you subtract 6 from everything, you get negative 42, less than 3x, less than 30. And then you divide 3 by everything, you get negative 14, less than x, less than 10. And that's your graph, okay? Right here, you're going to have negative on this side. It's an and because we're less than something, and the positive over here. And here you need to be careful because this might come out to be some sort of negative sometimes. And so you got to think about where, well, here, let's see. So if I subtract, so if I solve this one, and then I solve this one, and I got to also solve the outer one where negative 4x plus 12 is less than 4x plus 12. So I'll solve this one on this side first. So if we add the 4x, so this becomes a negative 4x plus 12 less than 2x minus 8. This becomes 2x minus 8 less than 4x plus 12. And then we also need a negative 4x, ooh, it's a minus 12, minus 12 less than 4x plus 12. And if I add 4x and subtract 12, we get negative 8, or positive 8x is greater than negative 24, and we get x is greater than negative 3. Here we get a 2x greater than negative 20. We get x is greater than negative 10. And then here, if we add, we get 6x, and that is going to be a -4. And we get x is greater than -2/3. So we need to be greater than -2/3 and greater than 10 and greater than 3. And so these all need to be true in order to make this true. And so we just get that x is greater than -2/3. Okay. Over here, we get the two equations. They're an or. So either this is greater than that or it's greater than the opposite of that, which if I put parentheses, I would remember to distribute that negative. Okay. So here, if I subtract x, we have 3x, and subtract 3 less than 7. We get x is less than 7/3. Or here, if I add 4x, we get 5x, and I subtract 10 is less than -13. X is less than -13/5. And it's an or. So it's either less than this negative number or it's less than this positive number. And if either one is true, I'm going to pick the 7/3 and put it below that. Okay. And then we can see ones like this. All right. This right here is kind of a mess because 3 needs to be, so this one is here, I'll write it up for you. Okay. But this, since it's greater, is an or. This, since it's less, is an and. And so we actually split up into two statements where this is greater than 3 and, because it's in the middle, this is less than 15. And the or can be split up into 2x plus 1 is greater than 3 or less than -3. And this 2x plus 1 is between -15 and 15. Okay, so if I subtract 1 everywhere, we get 2x greater than 2, 2x less than -4, and that's an or. And then we get and, subtract 1, we get -16 less than 2x less than 14. Divide everything by 2, we get x is greater than, just a regular x, greater than 1, or x is less than -2, and x is between -8 and 7. So if I plot all of these, we have -8, -2, 1, 7. And this one, we're either greater than 1 or less than -2. And up here, we're either, we're between those two. And if it's an and, we need both the red and the green to be true. We end up with this solution, which is from -8 to -2 and from 1 to 7. Okay. This one, how often is an absolute value less than -2? Never. Okay. And then finally, find the absolute value to represent this graph. You need to start with the midpoint because then this is the distance that we need to be less than. Okay, so whatever this midpoint is, so it's like the absolute value of x minus the midpoint is either less than or greater than, depending on what we're dealing with, greater than over here, less than over here, whatever the distance is to the endpoint. Okay, so what's the midpoint of -8 and 3? Well, if you add them up and divide by 2, -8 over 3 or -5 over 2 is -2.5. So x minus that is x plus 2.5, absolute value, less than or equal to, because we want to be within that distance of 5.5. Over here, midpoint's a little easier because we get an even number. Those add up to -8. So -4 is half of that. And this distance is 16 on both sides. So we get x plus 4. We subtract the -4 is greater than 16, right? This one has the or equal to because of that or equal to right there. So good stuff. Have fun. We'll see you soon.